Hi students, welcome to Study Smart channel. Today we are going to study one of the shortest and simplest chapter of Form 2 Science, Chapter 6, Acid and Alkali. Let's start. Let's start with understanding about water and acid first. Do you still remember how a water molecule looks like? Yes, water consists of two hydrogen atoms and one oxygen atom. Water can split to form hydrogen ion and hydroxide ion. At the same time, acid also is a molecule that can split apart in water and release more hydrogen ions. A common example of acid is hydrochloric acid. When hydrochloric acid is added to water, it splits into hydrogen ion and chloride ion, increasing the number of hydrogen ions in the water acid solution. Now, moving on to understanding alkali. Alkali, or also known as a base, are molecules that can split apart in water and release hydroxide ions. The most common example of base is sodium hydroxide. When sodium hydroxide is added to water, it splits apart into sodium ion and hydroxide ion, increasing the number of hydroxide ion in the water-based solution. So, what is acid and what is alkali? Solutions are classified as acidic or basic based on their hydrogen ion concentration relative to pure water. Acidic solution have a higher hydrogen concentration than water, while basic solution have a lower hydrogen concentration than water. Typically, the hydrogen ion concentration of a solution is expressed in terms of pH. So, in summary, acids are the molecules that can split apart in water and release hydrogen ions, while alkalis are the molecules that can split apart in water and release hydroxide ions. I hope now you understand the definition of acid and alkali. Now it's time for us to see the properties of acid. Acid tastes sour, change blue litmus paper to red, corrosive, and react with metal to produce hydrogen gas. As for alkali, it will taste bitter, change red litmus paper to blue, it is corrosive as well, and it do not react with metal. So, the common things about acid and alkali is that both are corrosive and they both show their properties only in the presence of water. So now let's look at acid and alkaline indicators. What are indicators? An indicator is a coloring that changes its color based on the substance being tested. The change in color observed can be used to determine if a substance is acidic, neutral or alkaline. So, we have total 5 types of indicators and you need to memorize the change in color for both acidic and alkaline substances. Sounds difficult, right? Let's make it easy using our Study Smart tips. First of all, we just want to focus on the color changes in alkaline substances, as acidic substance mostly result in red color except for phenolphthalein indicator. So, in order for you to memorize the color change for alkaline substance, remember the sentence, USA princess must be rich because princess young, beautiful and bright. So, how to use this sentence to memorize the color change for alkaline substances? Well, first, let's have a look on the first part of the sentence. USA princess must be rich. The U in USA refer to the universal indicator, the P in princess refer to the phenolphthalein, the M in must refer to the methyl orange, the B in B refer to the blue litmus paper, and the R in rich refer to the red litmus paper. Now, in order to memorize the color changes in alkaline substances, we look at the second part of the sentence. Because princess young, beautiful and bright. The B in because refer to the color blue, the P in princess refer to the color pink, the Y in young refer to the color yellow, the B in beautiful refer to the color blue, and the B in bright refer to the color blue as well. If you memorize this sentence, you can memorize this table in less than 2 minutes. Good luck! Moving on to the topic pH scale. pH scale is used to show the strength of acid and alkaline substances. The range of pH value is between 0 to 14. Any substance with the pH below 7 is considered as acidic, while those substances with the pH above 7 is considered as alkaline. For acidic pH range, battery fluid has a pH of 0, while milk has a pH of 6. This shows that battery is much more corrosive than milk. As for the alkaline pH range, blood has a pH of 8, while bleach and drain cleaner has a pH of 13 and 14 respectively. This means that bleach and drain cleaner are much more corrosive than blood. So, what we can conclude from this table? The lower the pH value, the stronger the acid, while the higher the pH value, the stronger the alkali. Now, let's have a look on the common acid and alkaline we use on daily basis. First, we have vinegar that we normally use for cooking. Vinegar is made up of acetic acid. Next, we have sulfuric acid in battery fluid, citric acid in the lemon juice, and carbonic acid in soft drinks. As for the base, we have sodium bicarbonate in baking soda, potassium hydroxide in soap, ammonia in fertilizer, and sodium hydroxide in washing powder. So, we are surrounded with acid and alkalis in our daily life. Last but not least, I would like to end this video with some smart tips for you to remember when you are dealing with acid in your school laboratory. When you are mixing acid with water, it's very important to remember that always add water first, then only acid, never the other way around. This is because adding acid to water helps to control the reaction because acid can release a lot of heat when they dissolve in water. If you add water to acid instead, the heat generated will cause the mixture to splash and potentially can lead to burns or other accidents. So, always keep in mind about safety when you deal with chemicals during your experiments. Alright students, with this we have successfully completed the 6.1 properties of acid and alkalis. Until we meet again in the next video, thank you and have a nice day. Bye!